So, and this will be in charcoal English, so my apologies. Well, nice to see you all tonight, and I would like to welcome you all at the Saxum office. For people who don't know us, feel free to ask any questions afterwards to my colleagues with a name badge. They will tell you everything about Saxum and what we do. And if you don't want to know anything else about Saxum, just take a beer, enjoy the food, and enjoy the meetup. Tonight we have got two speakers. One is already present, and she's Jamie Maria. She will talk about progressive web apps, and after Jamie, Peter will talk about GraphQL. Peter is sitting over there. So I'm excited to start, and I will give the floor to Jamie.
All right. Good evening, everyone. How are you all doing? You ready for the second round of talks? All right, thank you guys so much for having me over here. My name is Peerdeman. I'm a CTO at Lively, which is also a digital agency, quite like Saxum. Yeah, thanks so much for inviting me. I know a couple of people from the Saxum and Noun crowd who have seen my presentation at a conference about GraphQL. I'm a big fan of it, so I'd love to share some of my insights to you. So as I said, a Lively digital agency that does digital decency. Just as a little bit of a context, for a company in Amsterdam, the northwest of it, with 22 people. We work on delivering digital products for our customers. So no websites and campaigns, but like real deep business project, deep business process automation. So we do product consulting, concept design, development, DevOps, and culture and knowledge transfer as well. So we help people get up to speed with things like React Native, and GraphQL as well. All right. So without further ado, this is quite verbal. Yeah. We build big full stack apps for our clients. And maybe a little bit of history, how we got to be at this place of this great new technology of GraphQL. So when we started about, I think it's about 5 to 6 years ago, we started doing some experiments with NodeJS, and like the first things that we did were a little bit of PHP. We got into NodeJS pretty quickly because we thought it was pretty cool, and we liked JavaScript a lot. And then we turned into Meteor. Who here knows about Meteor? That's great. So it's a full stack JavaScript framework that you could use to do real-time communication with the frontend and backend really easily. It was really easy to get started with that. So we adopted it. We were quite early adopters of it, and we created some great real-time applications. It sort of has got this vibe over it that people don't like it that much. But we were actually quite pleased that we were able to build applications with this, because it got us started with like full stack Node.js projects. So as some of you might know, the team of Meteor switched over to Apollo, and we were really following these guys. So we got into the Apollo stuff quickly as well, and they came up and they also worked with this thing called GraphQL, which really got us interested. So we were really early adopters of GraphQL, so we switched back to basically plain Node.js and finished our stack off with the GraphQL. So at the moment we use like plain Node.js with the GraphQL layer, and we don't use the Apollo server, but we do use the Apollo client. All right, so it's like the stack that we're using now with the React Native part being a nice extension of our React app as well. All right, so back in the day when we started creating these web applications, we wanted to be as restful as possible, because this was the cool thing to do, right? You wanted to adhere to the spec as good as possible, but I mean, it wasn't all fun and games. It was nice that you could specify your entities, and that you could retrieve your entities in a very sort of approachable way, and you would actually know that if you go to /API/users, you would get the full list. You would go to /users/1, you would get the first user, which was great, which was great. But there were a couple of things that we did not like about it that much. So it's got a couple of problems. that I'm sure a lot of you have seen as well. So for instance, you have the nested data. I don't know whoever created a REST endpoint that does embedded data, but in a way it always feels a bit like cheating, and always feels a bit like, well, if you go to /user/1 and you actually add some of their friends' data in there, it's not really a REST, is it? It's a bit like RESTful, so it was almost impossible to really create a REST application like completely following the spec, because your front-end team would just ask, well, I don't just want the user, I want to show some of his friends' data on that page as well, so please just stuff it in there. And so, or you would have another backend that would say, well, no, I want it to be pure, so you're just going to go to /API/users/1/friends, and you just do 2 calls. But then basically you get into the callback hell, and of course we solved this callback hell by adding, sprinkling a little bit of promises in there, and I mean it was nice, but still you had to do multiple calls, and it was basically awful. So back to the embedded queries. So when you actually add another entity inside the entity, people got really creative with parameters. Everyone invent a parameter in this room to include some extra data? No, probably so. So maybe you would say like you would have a front-end team. They would ask your user data, and they would just want the data with all the friends in there. And then you would have the mobile team. They would say, oh, you just want the friends list because we're going to show we just want the user and not his friends list. We'll add it. We'll question it in the second request. And then they would just add a parameter like mobile is true to the REST endpoint, and it would be, and of course it would give back this data, but it would not be that pretty and not that predictable as well for the front-end team. You just have to figure that out. Then the response format. So if we look at what a REST endpoint should return, there's not really anything defined there, right? So sometimes you would just get the data immediately. Sometimes it would be wrapped inside a response object with some extra metadata in there. But basically, you would get random content, and you just have to find out if it actually returned the thing that you wanted to return in the format that you have made a contract with your backender, and would hope that in the end it would actually be that format. Then we have the entity-less methods with side effects, which I also found. I've searched far and wide through the REST spec to really find out if there was a nice way to do this, to actually have like a sort of a method that you could execute on a certain entity. And you could do things with posts, or I've even seen the link HTTP verb being used to maybe link some stuff together, but it just didn't feel that RESTful. It didn't feel that good. And documentation ? You can probably see where I'm going with this. I mean, okay, Swagger was okay. It was better than just like randomly going through notes that someone written down in some far drawer put away somewhere to find out how to get your data. And I mean, Swagger was okay, but you did have to be very disciplined to actually maintain it. And then versioning, yeah, that was a pain as well. I've seen multiple APIs where you would have to be compliant to previous versions for a long time, and you would have methods pointing back to V1 versions or something that was completely old. Well, it is still a mess, of course, but GraphQL has some nice idea of this as well. So GraphQL, what is it really? Maybe a round of hands. Who already knows something about GraphQL? That's good. So a lot have seen it. So who has actually created something with a GraphQL backend? Okay. And who is a front-end developer that has used a GraphQL API? Okay. You all are having a good time at the moment. So when people ask me what is GraphQL, I would explain it as it's a query language for APIs. And people get really sort of confused with it because it feels like, oh, so we're going to create a query and we're going to just send the SQL statements over again like we used to do back in the day when when our PHP applications would just accept my SQL statements and just query the whole database. But no, this is not it. It's a query language for APIs. So instead of sending a GET request, you do it in a different way. So imagine we're creating this front-end application. It's a single-page application, and there's a couple. It's a dashboard, and it has multiple pieces of data. So if you look on the left side, it would have some course status data. If you would look at the top right, it would have the last 3 enrolled students, and at the bottom right, you would have the top due payments. So if you would be developing this single-page application and you would be using REST API, it would probably look something like this. So I think the lettering is far too small, so I'll just explain what it says. So at the first query, you would get the data from the first part. In the second one, you get it for the second part, and maybe even have some data that's retrieved, and you would actually have to use in your third request to actually get the third piece of data. So you would have 3 requests that would all do a round trip to the server. So it might take a while if you're on a mobile device. You would get all this data back, and you would aggregate it in your front end and show it, and then be happy that you've just sent 3 requests into the world. And if we now look into the GraphQL way of how this would look, and maybe I can increase this a little bit, is it better? So we could see that at the top we define a query. So the front end defines a query, and you would actually see a certain user entity being queried. You can pass some parameters, so specific ID on the top. You would say, I specifically want the name, the posts, and from this post, so post would be an embedded entity, you would actually see a title and some followers. So you would basically, instead of having one call for the users, one call for the post, and one call for the followers, you would have one query describing how this embedded entity would look like. And you would just get one response back, which would actually contain the data that you requested, and only the data that you requested. And that's a big part to see here, because if you would call a REST endpoint that would query a user, you would probably just get back the whole user object. But here you say, I just want the name and maybe some posts. So this means, this is all great and all, like this protocol. But these good standards need good tools as well. So with REST, we've got some great tools like Postman and Insomnia and all these tools that will help us create queries and save them and replay them over and over again, and configure the data properly. GraphQL is shipped basically out of the box with a great tool called GraphQL. And that's what I really like about this technology, is that when it basically started and when it was originally open sourced by Facebook, it immediately shipped with this great front-end tool that would allow you to explore this API in a very intuitive, very friendly manner, which I think is like one of the main reasons for the success and the quick adaptation of this technology. So let's take a look at the graphical interface. So I'm going to show a short demo here. What you see here is a web interface. So if you create a server running with a GraphQL server, you can enable this. You can enable this sort of debug interface and open it in your web browser. And what you're going to see is a piece of code on the left side, so a code editor on the left side, and the results on the right side. And everything you're typing, you can actually autocomplete. So if you press the Control spacebar inside this tool, it will actually autocomplete what is possible to fill in. So if we look over here, we're going to create a query, and I immediately smashed on the autocomplete. So we're going to retrieve some course materials. And in this course materials, we enter the parameters that were there. And this tool is really helping us build this query. So we can see the results over there. So here we're looking for locations, and we can see inside the autocomplete that even the parameters that you're able to pass are all being auto-completed. So here we're searching for locations in Mordor. So it's taken as a reference to one of my conference talks. Here we're looking for groups, and you can see that both for the entities and for the parameters, all the values are being auto-completed. So you can see exactly that groups contains the date from, and for instance has a couple of students in it called learner users, and from this user you could actually query the idea. And if we play this out, you see that both the course materials and the groups will actually respond with exactly the data that you requested, which is pretty neat. The first time that I was using it, I would encourage everyone to try that.
Sorry to interrupt. Can you maybe increase the font size a bit?
Yeah, I'm gonna try making it even bigger, but it doesn't look like the video is getting much bigger. Maybe I can zoom it in for the next one. No. Oh, this one. Yes, I'll try it for the next one. Let's see, where was I? I was talking about how you could use it yourself as well. It just jumped into my mind. I don't have it in my slides, but GitHub has exposed their API in GraphQL as well. So it's a very nice API to just browse around and to find out which repositories you have and which repositories are started. It's a great way to try out the graphical interface. All right, so just sit back for a while and let this ponder your mind for a second. Any front end can write its own query for exactly the data they need from the API. So there's a couple of key things in here. Any front end, so you could have your web application, but you could also have your mobile application. You could even have your chatbot, or I don't know, any other front end that you can think of, querying your API for a specific set of data, and for exactly the data they need from the API, so they can only get the subsection of data that they want, which is pretty powerful, and is also, of course, a great attack vector. Of course, we'll probably get some questions about security as well, but if we look at this from a convenience point of view, like DX, like developer experience, this is totally awesome. All right, so maybe look at some code how we're going to query such an API for the people that have not used something like this before, or what it would look like. So I've created one example that's just vanilla JavaScript, so you're not going to need anything more. So I don't know if it's readable, but we'll just give it a go. So the first variable that we're defining here is a piece of text that is actually copy-pasted from the graphical interface. So you would use the graphical interface to interact with your API and just figure out the data that you would want. You would basically just copy-paste this whole piece of text into your code and save it as a variable. Then you just do a fetch, a regular fetch, as if you would call any REST endpoint. You would send it to /API/GraphQL, so you would always send this request to one endpoint, so all requests will be made to the GraphQL endpoint. You would specify the post, you would specify that it's a post, you would say that you would want to retrieve some JSON, and then the data that you get back the body that you're sending to the request would be a JSONified string, a stringified JSON with a query and the variables that you want to send along. And then you would just retrieve the data and do anything you want with the data. So this would be like just doing a simple request. Well, what about manipulating data? What if you want to change something in the API? Because querying is great and all, but every now and then we want to maybe favorite something or enter some data or do something else. Well, there GraphQL talks about mutations, and this feels, first time that I saw this made me feel a little bit like doing an RPC call again. There were going some hands at the previous talk for Flash developers. I saw a couple of hands rise. Who still knows about RPC things in Flash? That was awful in its own ways. but it does allow you a lot of freedom to define what the mutations on your API would be. And this idea that you're separating, retrieving data, and doing this with queries, and actually mutating data by doing it with mutations is something that I really like. All right, let's see if we can go full screen. That's great. Thanks for the suggestion. All right, so we continue where we were before. We've got the query over there, but if we remove it, we can say we actually create a mutation. And now we're going to see all the mutations that are available. And we've basically made a namespace for ourselves to say whether or not you're creating or updating or deleting something. So you're specifying here what kind of parameter that you're sending. And of course, it gives you auto-completion as well, like what's wrong with your query. And so here it's clear that we're going to create a new course material, and that means that we have to pass the interface some course materials. And then, because the interface is strongly typed, we have to say we actually create course material input type. So, nice effect that you see over there. We have the error handling also giving very nice error messages. All right, so I was fixing the problem over here. We're going to add some query variables. This is the second part of the GraphQL part. And we're saying we're adding a course material that actually has a name out of the mirror drag. And we created it, and you can see the result on the right side of the screen, which is the entity that was created. It's a lot to talk about in one part. So lots going on, but probably some of you have seen this, right? Maybe the hands for people who've already seen a graphical interface. Okay, yeah, that's good. Yes, you really need to try this out for yourself. It's really powerful, really cool. All right, let's see. Hold on. Screen interface. All right, so in the previous sample that we saw, we were actually using plain JavaScript to do a query, and I mean maybe there's a couple of jQuery developers still out there doing it in this kind of way, but now people are using it inside single-page applications. So a little bit of a more advanced example how you would use this in React, and actually use Apollo as a library to sort of ease the way of passing these parameters and giving you some extra functionality inside your React application. All right, let's see. So here we go. We have on top we're importing two libraries. The first one is GQL from which is called graphical tag, and it will actually help you to define your GraphQL statements inside your code. And the nice part here is you get this tag GQL and with a backtick, and you still paste your GraphQL query inside this field. But the nice part is that now your code editor will actually recognize that you're writing GraphQL here, so it will correct if you've made any syntax errors. And recently there have even been plugins created that will actually attach to your GraphQL API, so you can actually inside your code editor also autocomplete your queries, which is pretty awesome. You need to do some setting up to get it to work, but it will really help you shorten this process even further. And then the second module that we're including is the query component from the React Apollo library. So if we continue, we're creating a new component. We're going to call it the course materials container component, and it will actually use the query component. I don't know how many people in the room know React here. Okay, that's good. So you probably know how an component is created. So we use this query component, we pass the query that we've defined before, and then we can create our own material of our own component below. And you can actually see that there are some extra variables that are instantly available, a loading variable, an error variable, and a data variable. So you're not just getting the response data, but you're also getting an element that says, or a boolean that says whether or not this thing is still loading. So this would mean during the call, you can actually use it to display an error state. So here we have if error, then return the error, the error component. And if loading, return the loading component, or you show the message or anything. It's just a very nice convenience that you don't have to basically do all this wrapping yourself. And if this is not the case, then we return the course material list, which we pass the data course materials that was requested using the query object. So it's just wrapping your React component with one thing, and it will just take care of everything, which is pretty awesome. So you could have multiple components on your screen, and then using the query object to get the components their data. All right, so now that's great. Now showing something fancier, because probably some of you have already seen this. If you're using the Apollo library, you get some extra functionalities as well. There's a couple of them that I wanted to talk about. So, for instance, you can pass these objects a certain poll interval, which would actually help you poll a certain GraphQL query multiple times if you want to do sort of a poor man's real-time application. You can do prefetching, which is pretty cool. So if you would see, for instance, a table list, and you hover with your mouse over the list, you could actually prefetch the GraphQL query that would be on the detail behind the list, and actually prefetch the component from that. Prefetch the data for that component. So when you scroll over the list, it will actually already do the query, and when you click it, you instantly see the data. Then we have the fetch more, which is, from my point of view, one of the cleanest ways of doing infinite scrolling in applications, which just specifies a method, what method should be called when you go to the next page of your table, which is great. Then we have the update for optimistic response. So in a previous talk, I've delved into this a little bit further, so you can look it up if you're interested. But this is also a pet peeve of the Meteor project, that you could do optimistic responses. So this would mean when you, for instance, update some data, you could create an optimistic response. What the server might return once the query is finished. So, for instance, it might take a while for a backend process to take place and to return a response, but in your front end you can actually immediately show a result before it actually happened on the server. And then when the result comes back, you can either just leave in the predictable sense. You can just leave the interface as it were, or revert the interface if an error occurred. And then we have the subscribe to more, which is one of my favorites, is creating a GraphQL subscription. So you could actually do a real-time subscription on data, and then have the server being able to push data towards the client instead of the client having to like poll the server or refetch the data. So a little example on how this would look. So we see a little bit of familiarity with. Let's see. No, it's not. All right. So now we have a payment subscription. You can see the same GQL tag that we used before, and now instead of a query or a mutation, we're describing a subscription. So it's sort of an extension of the GraphQL spec that was also the Meteor team helped them along developing this real-time subscription data. And here you say, I want to subscribe to the payment edit subscription. You can pass it some parameters. So you say, I would want to be updated on this payment. And this would actually be the data that you would retrieve from the subscription stream. So you've defined the data, and we have this payment query result object. And I will not get into like full detail on what's going on here, but bear with me. You need this query result object. And then you have your React component. You have a component did mount function, and here you would actually use this payment query result object and call the subscribe to more, and then see that you have a document and an update query that will actually contain the payment data that's being pushed from the server to the client. And once this data arrives, you could call merge new payment in data query, basically containing the previous data and the new data, and you can decide for yourself how you're going to update the state, and it will reflect then in your React component. So it's a bit, I have to say that it's maybe a bit convoluted, but it's really cool way of being able to stream this data over as well. So for us, we used it in one of our projects, and it was like the big proof of concept, big unknown question marks at the user story prediction, but we actually got it to run within a fairly short amount of time, and we've created a very nice application with chats and sort of online statuses using this subscription model in GraphQL. All right, so GraphQL subscriptions, really cool. All right, so now we get into the second part of the presentation, which is the GraphQL FPP, and this is probably not a term that exists, but I've seen it as the frequently posed problems. So I'll just see if I can already answer some of the questions that might be arising inside your mind. And let's see. So number one, we don't use JavaScript on our backend, which is fair, because there's plenty of other backend languages, of course. And even though the specifications, how to say this, the comparison spec, comparison implementation is written in NodeJS, there's actually GraphQL packages for all other kinds of languages as well. So of course they're there for Node.js, and I think most people using GraphQL are actually using Node.js, but there's packages to create this interface for C#, Java, Python, and even PHP has a module that will allow you to create GraphQL queries as well. I do have to say that sort of because in a GraphQL query each of the fields is resolved asynchronously, basically, or has a lot of it's basically inherently asynchronous. It does feel like Node.js is or any other event-based or long-running process feels more appropriate to use GraphQL in. But of course, you can use any of these other languages as well. And probably for the subscriptions, it would also, for the GraphQL subscriptions, it will also make sense to have a long-lasting process to be able to send stuff from the server to the client without doing request response like PHP. But actually, we had the PHP meetup at our office lately, and they did convince us that there was a way of doing this in PHP properly as well, but I didn't look into it. All right, number two, there we go. You don't get any decent caching, do you? Because you're basically calling one endpoint over and over again, so the whole HTTP cache mechanic doesn't really work there. And I mean, this is true, you know. You don't get the HTTP caching in a similar manner. You could still see that the request body contains the same values as the previous request, so you could do some HTTP level caching there. But in the end, it's true. You do lose this HTTP caching, but of course you can still cache your data inside the API layer. And it's also something that's done using, for instance, data loader on the backend to make sure you don't query the same data over and over again. I see someone raising their hand in the back, please.
Yeah, a way to still implement this by just hashing the query. Then you basically get caching for free.
Yeah, so the argument in the back is that if you would hash your query and save the result from this hash, you could actually just deliver the same data again.
You get your HTTP caching for free.
You get your HTTP caching for free.
Yeah.
Yes. So that would work if it's like completely like public data.
Yeah.
That's not personalized, and that's not how do you say this, dependent on a specific user. And maybe this also wedges into my stance on this, is that the kind of applications that we are creating is mostly user experience, user flow heavy administrative applications where people go through many screens and you have a more sort of a controlled population actually using these applications. So for us it's not that big of a deal, but I've also seen much larger organizations, much larger audiences and consumers using the same thing, and it's more of a challenge, but you're also able to cache this data using, for instance, a Redis cache while resolving the data and not hitting the database every time. All right, number 3. And then we get into the security argument. Querying fields from our front end doesn't sound so secure, and this makes perfect sense. If you're able to basically query anything or drill deep into a tree structure, and for instance go to the Facebook API and say, well, I want to request my profile, I want to request my friends, and from my friends I want to get their friends, and from their friends I want their friends, well, you're basically blowing up their server. But there's multiple ways of going around this. And I mean, we've blown up our servers as well a couple of times when you do the wrong query, or for instance, you forget to add the limit 3 or limit 10 and query one of your biggest entities, then yeah, you're going to hurt your server as well. But there's a lot of things that you can do about this, these issues. So every field has a resolve method, or is able to have a resolve method, and can be guarded in the same way as you would guard a REST endpoint. So on the back end, every field that you're requesting, so when you're requesting the user, you can actually specify that if you are trying to access the confidential information, that you're checking whether or not the user is logged in, and you could actually guard every field separately. And of course, this is it's a bit of a puzzle sometimes. It's one of the harder things that we're encountering when we're developing our GraphQL applications. But you can make it as secure as a REST endpoint. And for the thing that I was talking about previously, like the different amount of queries that people are able to query from your project, you can actually make a list at compile time of all the GraphQL queries that are present in your front end, and actually only allow the queries that you've actually the front end team has actually come up with, instead of opening your API for anyone to basically query any data, or for instance limit the amount of levels that you can nest your data in, for instance. So these are all possibilities that you can protect your API from getting overloaded. All right, so those were the three big points. So a couple of the highlights that I wanted to impart before we say goodbye. Typed auto-documented API. So because I've not gone into so much detail for the GraphQL backend, but every entity that you see and every field that you see is actually strongly typed inside the backend code. So this would mean that when you specify I'm going to have a parameter that's limit, it's going to be an integer. And this means, because it's defined in the code, you can actually generate the documentation for it, and you know that it will always be up to date because it's written in code. So this API will actually auto-document itself, and you can even add sort of descriptions with it, with comments, but even without comments, it's already super descriptive if you use good names. So linked data hydration by default is one of the biggest advantages that we see, is that when you have nested data inside your application, you can the GraphQL spec just gives you a very nice way of drilling down and getting this embedded data as well. Then we have the versioning. which would actually take place by creating new fields, and you can actually deprecate certain fields and warn front-end users that certain fields will get deprecated in the future. Yes, so on a field level, you can actually version your data. You can easily consolidate your microservices legacy into one API. That's also an interesting topic that we've been talking to a couple of more corporate clients. And I always give this example of, for instance, KLM. They have multiple big services like the flights, the booking, and the profile information. It's all separate microservices. And they actually use small GraphQL interfaces that get combined into one big GraphQL interface, where you could, from a front-end perspective, create one query that will get to both the booking information and the profile information. So also for bigger microservice-oriented architectures, it's a great way to sort of integrate your APIs and to give front-end developers a nice, explorable interface on what data is actually available. And of course, sort of the greatest part, it makes collaboration between the backend and the front-end team like really great. And that's one of the things that I'm most proud of at Lively. We all develop all our stuff in JavaScript, and then we switched to TypeScript recently. So both backend and frontend teams use the same language, and with GraphQL, this layer between frontend and backend has become even smaller, and it has become easier for frontenders to experience what is available in the API. It's been easier to sort of document and discuss with each other what the APIs would look like. And you can also see that our front-end team is now more eager to sort of discuss new APIs with more back-end focused engineers, and even creating stub queries or stub mutations inside the backend, and discuss how this would look like with the backend team, and being able to immediately integrate it into the front-end application. It's a great development. And you have this nice Apollo client, which does data management and caching. I did not go into it that deeply, but it will also help with performance for the front-end team. Alright, so if you want to get started with this stuff, there's a couple of very nice resources that I wanted to recommend. You have the How to GraphQL tutorial by Prisma. It's a free one, which is very extensive. It really shows a lot of stuff already. I was actually quite surprised that it's free. And then you have the advancedreact.com course by Wes Bos. I'm not being endorsed by him, but I really like this. I really like this course. We use it at our company to introduce people to GraphQL and React as well. And it's how to build an application in React with a GraphQL interface built in Node. It just goes through everything in a very, very nice manner. And before we stop, of course, we're always looking for people, and we'll not go into it too much. So come visit it and check it out. And thanks so much for your attention. All right, let's see if we can hit the lights and get back to life again.
The mutation part of the talk, because you mentioned it uses RPC, which is something I really like, by the way. And I was wondering if it's mapping to the GraphQL. It's probably something I can Google. I'll probably do it later anyways. But whether it's mapping to the GraphQL engine to run the mutation, or if it's mapping to some function on the server that you wrote that it will run.
So when you call a mutation you do access the GraphQL layer. So there's a GraphQL middleware that you enter into your Express Express server, and once this mutation hits that middleware, it will actually just call the function that is linked to the name of the mutation. So it will actually just call your defined function that you've mapped to.
All right, so it's just like mapping the request to the right function.
Yes.
Because
it's not that magical. No.
Yeah. I was wondering, like, if you're already using GraphQL for querying, what it is basically, you can always just use a post request for these kind of edit things.
Everything is post request.
Yeah, but I mean, if you want to edit things instead of mutations, do you also use normal post requests as part of your application, not just everything going through and back and forth through the GraphQL layer?
Oh, that's a good question. So, if you create your backend, and you could have REST endpoints and your GraphQL endpoints, and sort of mix these two worlds together. But in the application that we mainly use, we just have the GraphQL endpoint. So there's no posts being made to /API/users, but everything is done through these mutations. And I would also advise to use GraphQL as this integration layer. And for instance, if you would want to post something to a REST endpoint or a third party or a microservice that you've created somewhere, you could write a mutation in your GraphQL integration layer that would actually do a post to some REST API. If that makes sense to you.
Yeah, like doing some side effects to get some data back. Yeah. I understand. Thank you.
Any other questions?
Nice presentation. About the was it the tool,
Graphical.
Yeah, graphical. So how does the tool know? So you do code completion. So does it hit the server every time? Like, okay, or is it on somewhere the scheme should be defined, right?
Yes.
Otherwise you cannot do the code completion.
Yeah. So the idea is that the GraphQL endpoint will actually expose the types and the documentation through this endpoint as well. So once you start the graphical interface, it will retrieve all the types and use it to autocomplete.
Another question is like, is this testable, unit testable?
Yeah, it's basically you're doing a post request. So you could create a unit test that would enter a certain GraphQL query, and it would just run the query just like you would do an integration test on your REST API.
I think that GraphQL is based on HTTP, but the observer or subscribe portion, that's WebSockets.
Alright, so the question is, the GraphQL queries and mutations are all HTTP request responses, that's true, and but what about the subscriptions? In the specification for the server and the client, they have sort of separated out the transport layer and the way that you define the subscriptions. So you can actually write any transport layer that allows bidirectional communication. So you could do strange MQTT things or fancy, I don't know, other ways of doing this. But usually the first transport layer that's used by everyone is a WebSocket. Layer. Yeah.
And that's by default, or you have to specify this?
So you configure which transport you're using, and when you look up all the tutorials and the examples, basically they mostly use the WebSocket implementation.
Okay, thank you.
Yes.
Hi. How do you handle your state management?
How do you handle your state?
Do you use, yeah, of course. So do you, for instance, use something like Redux, or do you actually use Apollo? And that will be link state, probably.
So We've tried using Redux every now and then or something. I think we've done multiple sort of proof of concepts to try. I mean, everyone is using it, so there must be something in it. But we found that it's quite a big overhead and a lot of sort of how do you say this? A lot of files that you have to edit to get something working. We're creating quite big applications now with about 400 pages. Still just using the Apollo client in a similar way that I've shown in the demo. Internally, the Apollo client uses the React context to store its data and to sort of do some smart stuff with caching and making sure that if you do multiple requests to the same resource, it will actually fetch it from internally from this context. So they've solved it with the React context part, and they used to actually use React to Redux under the hood of the Apollo client. But we have actually just stuck with the Apollo client and really liking it so far.
When thinking about data management, thanks for the presentation. When thinking about data management and mostly looking at devices with minimal resources based on your connectivity. For instance, you're in Holland, obviously on a mobile phone everything is hunky-dory. But there are countries with a way less connectivity. When I think about this concept, I see that every query basically gets run every time you need it, unless it gets cached. But you have a lot of unique queries in the end. If you have 400 different pages, for instance, you will probably have 400 unique queries. How does that perform over, not optimal device connectivity? Because I can imagine there's no caching basically over the same resource. If I fetch the same user 10 times with different fields, I'm still fetching the same user 10 times. Does that hamper your performance in any way, or does it still perform?
So, and there was a very interesting talk quite recently done on NodeJS performance. I can hook you up later. Where they were looking into the performance of GraphQL and how they could improve it. And if you look at it from a very basic level, just running a Node server and creating a REST endpoint that does something, or creating a Node server and using a GraphQL part, you could of course see that it was a little bit more overhead because, for instance, the types needed to be checked, and you would have this parsing of the query itself. But if you're really looking at the performance under the hood, there's not a big difference there. And I would even argue that if you would create your application in such a way that you actually use this aggregation of multiple entities inside your query, that because you don't have to do multiple round trips to the server and back, you could actually improve the performance, the total performance of your application, because you don't have to do multiple round trips or have one round trip that gets knocked out and you have to retrieve that second one. But I would argue that it's more about sparing the amount of round trips that will increase your perceived performance than actually the fact that you're using GraphQL or REST would actually do the same thing. You could optimize them both in their own ways.
Thank you.